All right. So as I just mentioned, today we're going to be making the connection of our entire project, or how the not necessarily the whole internet works, but how an application works, right? So we've seen this drawing before. We have our front end server. We have our back end server. And we typically have some sort of relational database management or some sort of database, not necessarily an RDBMS, but a database, even if it doesn't handle relations. So let's put DB here for our database. All right. So we've talked about how this process works. We go over to something like Amazon.com. A request gets sent to the server. Let me put that in green and let's make it solid. The server then says, oh, well, since you're sending a request for Baby University with the following ID, let me go ahead and query the database to grab that information. So then it talks to the database. The database runs a select query saying, hey, I want to select all information from books where ID is equal to 1. This is just an example, right? So then it grabs that data and returns it back to the backend server. And at this point, PsychoPG is interpreting that query set so that it comes back as a dictionary. From there, our backend server grabs that dictionary, formats it in a pretty way, or maybe we want to change some data or do some calculations with that data before we actually send it to the front end. And then finally, we send a response back to the front end, at which point the front end utilizes JavaScript to create an image, right? So we have a whole document.create element img, and it utilizes the response that comes back from the backend to set a source. So we can say something like, hey, well, now that we have our img there, I can say img dot source is equal to response dot book URL. All right. And then finally, this would get appended to the child. So div dot append child img. All right. This is definitely a shorter version of what is actually going on, and we'll see what's happening here shortly once we break into our lecture. But this is just a small example of how the front-end application is communicating with the backend server, talking to the database, and returning information. So at this point, we have our backend server pretty much locked down, working as its own separate entity, right? So we have created a backend server that is able to speak to our database. No, let's keep it that. Oh. All right, so let's keep that solid. All right, we've been able to create a Flash server that's able to talk to a PostgreSQL database. And we've also been able to create a front-end server utilizing live server, the extension. It opens up a server and it hosts our HTML with JavaScript and CSS to be able to decorate our classes and create images and or behavior with JavaScript. Well, now we're going to go in depth into how this request process actually works over HTTP and IPs. But before we start knocking into the actual content of today's lecture, does anyone have any questions regarding this small overview over everything that we've covered up to today? Okay, doesn't seem like there are any questions. So let's start talking about some of the acronyms that are common in today's world, right? So we have IP. Can anybody tell me what IP stands for? These are
I think it
different.
was Internet Protocol.
Perfect. Yeah. So we have the Internet Protocol, right? So the Internet Protocol is just essentially saying, hey, they're in the Internet, or we kind of see this inside of our machine as well. But in the Internet, you can think about it as sort of real estate, right? Inside of the internet, there's a bunch of tiny slots, and I finally fixed my keyboard. You will all be happy to know that. So that means my keyboard shortcuts are back. All right, so we could think about the internet as a massive machine that essentially just has a bunch of tiny slots inside of it that we can buy out or rent out, right? And when we rent out one of these machines inside of the internet, or let me just go ahead and add this in here. Internet equals massive machine. All right, this massive machine has a bunch of tiny little machines that we can rent out and utilize. So when I go into AWS and I make an EC2 instance, or I go into some other internet hosting site and I create where I want my site to live, it's going to return an address. It's saying, hey, inside of this massive machine, I was able to purchase the slot of 190.1.2.5.8, right? It's just a ridiculous series of numbers. And now when people go to HTTPS or HTTP slash 190.1.2.5.8 slash, my site will actually populate, right? This will be where my servers are living or where people can go to find my site. There you go. It will go into the internet, go into HTTP 190.1.2.5.8, and that will activate my entire stack here, where a server will essentially receive that request and either render some sort of HTML or return some data from my API. All right, what about TCP? Can anybody tell me what TCP stands for?
Transmission Control Protocol.
Yeah, so that's just transmission control protocol. And we're going to be diving deeper into what that stands for here shortly. But essentially, the way this works is we have a client and we have a server. All right, so a server is where our entire application lives. And then we have a client. As we've mentioned before, a client is essentially just anyone who is able to access a machine, right? So they go into their laptop, they go into their phone. They are all clients that are attempting to contact our server. Well, there's a three-way handshake that happens here. Now, the client contacts the server. Oh man, I don't like it when these arrows don't work the way I want them to. All right, here we go. The client contacts the server and essentially says, hey, can we talk? It's like a weird relationship that they have, I guess. And the server responds with either yes or no. If the response is no, we can't talk, then the client doesn't get any content, and that's where it all ends, right? There was never even a request wasn't even accepted. Now, we really don't see this first handshake ever happen until we get into Django and start talking about course. We'll get a small image of Django responding with no. But most of this communication here happens in the background without us ever seeing it. All right. So once we get back our yes, then finally the client says, hey, can I have index HTML? And then the server will respond with either sure or no. So it returns or responds with index.html as our template. All right, so that is what gets responded. And then finally, once this whole thing is completed, there is a final communication of, oh, let me change that to a different color. I got what I needed. And then this one just says, Okay, you got what you needed. And that's that, right? So the first communication, we never see it. We never see the last communication as well. This is essentially what kills the communication between the server and the client. You'll see this becoming important if you're working in some sort of server that requires a session. You're going to have to keep this communication open. So instead of saying, okay, it would say, oh, okay, well, let's stay connected. All right, so there's a couple of different ones. It will either close the communication and say, all right, we're done speaking, or it's going to stay connected and open up a session for this communication. But the ones that we do see is the ones in green, where the client actively requests for something from the server, and the server actively responds with some sort of content or data to the client. And that's our three-way handshake. Does anyone have any questions over the three-way handshake or the internet protocol? All right, if no one has any questions, then let's dive into today's slideshow, everyone. And let me actually make that a bigger screen here. All right, so HTTP, the web's protocol. Can somebody read this, please?
HTTP connects the world. Hypertext transfer protocol. Protocol was originally described in 1991 with their origins of hypertext dating back to as early as 1930.
All right, awesome. Thanks so much. So as we mentioned before, when HTML was first created, or the entire internet was created, it was for universities to be able to share research with one another that they've completed or that they've done. They needed a fast and effective way to do this. Now, with that said, they didn't really need much of, well, I'm sure they would have liked to have something like video and images and 3D diagrams and all the things that exist nowadays. But at the time, the technology wasn't there. So they concentrated on just having text showing up on the screen with hyperlinks to other templates with text. And that's how they were able to share research with one another. All right. So hypertext, the HTTP protocol was originally designed as a protocol for transmitting hypertext. The modern equivalent of hypertext is HTML. Today, HTML has grown to support much more than just linking from one page to another, but it was the concept of linked pages that uniquely defined the early web. HTTP has also found new use cases while transmitting HTML in a common use. HTTP can transfer any type of document or file. Today, HTML isn't even the most common type of document transmitted over HTTP. Images, CSS, JavaScript, API responses, etc. are far more common. Excuse me. All right, fantastic. So anything can be exchanged over the, or not anything, excuse me, many different types of files can be exchanged over the web. And we can see that in our actual inspector tools here. So if I come over to our inspector tools and I go to inspect, and I believe it's in network, there it is. All right, so in network, right now I'm just going to go ahead and refresh the page. All that we're seeing here populate, all these crazy lines that we're seeing populate and all this drop down menu that's happening down here, that is all the requests that are being actively sent from the moment I loaded the site. So in 6,000 milliseconds, I've made all of these requests, and you can see the duration of the request until completion as well. That's why it's so prolonged or dragged out. Then it's still making requests 26 seconds into the site. And you can see all the different files that were sent over. So here we have an HTML. We have more HTML. I have no idea what kind of file this is. Let's see, that's .wolf. Never heard of that. Here we can see we have some CSS being exchanged. Looks like an image was exchanged. All of these different files were exchanged. And here's the book image that we're actually rendering, or that's actually being rendered on the screen, right? Like if I copy this and I come over to another browser and I search that, we'll see that it shows me the same book image that Amazon.com is showing me here on the left-hand side. So all of that, all of these different templates or all of these different files to include avatars and stars, half-filled stars, those are all SVGs. I mean, it is a ridiculous amount of requests that just went through in the last 10,000 milliseconds. Right, so that's how the transfer protocol is working, and these are the different files that it's actually sending. And the network tab is really useful. We're going to get more familiar with it as we move forward inside of the cohort, just though this is a good way for you to see all the requests that are being made and whether they were completed or not. All right, moving forward. HTTP conversations, we just covered this. So HTTP describes a conversation between two parties, the client and the server. The client sends a HTTP request and the server sends the HTTP response. Both HTTP requests and responses are plain text. They're easily read by a human and each has a very simple structure. All right, and before I start breaking down what the structure looks like, we're going to be covering that here on this slide. So here we can see on the left-hand side, we have request. And on the right-hand side, we have what a response would look like. So we see, hey, this is a client. So this is somebody going on Google Chrome, right? And this is the user agent. They're telling us they're on Google Chrome. They went over to a site named example.com, and example.com automatically requests for a bio.html. So it sends a GET request for bio.html. When that gets received by the server then looks into the templates folder, finds bio.html, and sends it back. Once it responds, it says this request was processed. So it gives us a 200 OK. It gives us a content length of how long the response is, a date of when that response was completed, the content type. In this case, we're sending back HTML, which is essentially text, and HTML, head, title, we just see the HTML template starting to render. All right, and it's going to break all of these down here shortly. Okay, here we see the request line. A method is our get method. The URI, or the portion after .com, is /bio.html. And then we have HTTP, which is not HTTPS. It's saying we are sending this over Hypertext Transfer Protocol, not Hypertext Transfer Protocol Secure. The only difference is that secure will encrypt your request, while not secure will not encrypt your request. All right, and now we're going to go into methods, the different kinds of methods. We've talked about this earlier when we're covering Flask. We have 4 different main methods that we're going to be working with throughout the cohort. There is a couple of others that we won't be touching throughout the cohort, but here we have get, post, put, and delete. Get, which is for retrieving data. Post, which is for sending a resource or creating data inside of the database. Put, which is for updating data inside of the database. And delete, which is for deleting data inside of the database. I like to think of these all in relation to the database. All right, so now we have a URI, a Uniform Resource Identifier. And actually, I've covered quite a bit. Before I continue going on with the slide deck, does anyone have any questions over anything that we've covered up to this point? Let me make sure that Yankee Questions is pulled up as well. Okay, doesn't seem like there are any questions, so let's continue moving forward here. Our URI, it's what falls after http:/example.com/bio.html, right? It's the Uniform Resource Identifier. This is just saying, hey, this is going to send arguments or parameters. This is what happens after the initial rendering of the template, right? So that's how we get this get bio.html. We can see that we have a URN where we show only the host, example.com, and the URI, which is bio.html. And then there's URL, which is something we should all be familiar with, but the URL includes the transfer protocol, whether it's HTTP or HTTPS. And this is more of what we're familiar in seeing in today's modern world, is seeing an entire URL whenever somebody shares a link. All right, So now the HTTP request, we have the request line and headers. We'll be covering headers more in depth later on. We won't really be covering them during today's lecture, but in the headers, you can find really useful things like cookies. You can find things like tokens, other identifying factors that you can utilize will also likely be in the headers. And if any of you are familiar with working with third-party APIs that require some form of token authentication, you know that that's always being sent inside of the headers parameter as well. All right, now the HTTP request body. So it looks like this is some sort of store, right? Or maybe some sort of shoe browsing site, because what they're sending in the body is, hey, they're sending new Jordans and they want them in the color red. So if we go back to the example that we saw earlier regarding this communication up here, the slide deck that we're showing essentially sends a request, and I'm gonna type it out, but please know that we haven't seen this code yet. It's essentially saying sending a request to http:// example.com/bio.html, right? And inside of that, it has a body where it's sending, hey, I want shoes of type Jordan or new Jordans, I think is what it said. I'm just gonna simplify it and put Jordan here. And then it has something like color. And the color that it's looking for is red. All right, so that is all getting sent over to the server. Or that's our JavaScript that's our JavaScript code that's being triggered by the client. Well, inside of our backend server, we are grabbing this code. We're saying, hey, in request.body, and now we're going to do the switch to Python. I want to grab both shoes and color. And I believe I could do something like this. I may be wrong. Don't take my word for it. We'll have to check this. We'll have to check the syntax later on. Right? And then I can go ahead and grab from my shoes model. And we're familiar with models at this point because we saw this during our Flash server. And then I could filter where shoes, or maybe it's something like type, is equal to shoes, and color is equal to color. Right? And that would return, that would go into, let me make this smaller here. That would then go into our query at the database where it's saying select all from shoes where type is equal to Jordan. And, oh wow, this is a long query. Color is equal to red. Let me make that blue like the remaining of the code. All right, so that's what gets ran by the database. So that's what we've covered in code so far. We're sending a request that gets grabbed by the body. We grab those arguments from the body of the request, which is shoes and color, and then we query our database to grab this information. All right. So now we can see the HTTP request. Additional request data can be included as part of the URI. So we can see that you can also include it in the search parameters, or excuse me, in the URL inside where you type in the URL. So if I were to take a look at this and come over to my drawing, excuse me, I'm losing my windows. So right now, what we did is we just had bio.html, right? Well, the way that I sent my request earlier is I sent it within the body of the request. You could also do it where you have, now you have bio.html, a question mark will mark, hey, this is where the query starts. And then they would say, hey, shoes was equal to Jordan. And if there's any other parameters, they'll be separated by an ampersand. And then it'll say where color is equal to red. So it's just another way of sending the request. You could either send it within the body or you could send it within the URL. All right. And then something of key or something that's important to point out, you could utilize this percentage sign 20 to mark that there is a space, right? And that can get really confusing when you're working with some APIs that don't allow you to utilize the body. They expect you to only send it within the search parameters inside of the URL. So if you don't know how to put a space, it can get really hard to send your request and get the appropriate data back. So just remember, percentage sign 20 will mark a space on the URL bar. All right. Does anyone have any questions over what I've just covered up to this point? No questions. Let's continue moving forward. All right, so more about the request headers. Can somebody take a stab at this slide and read it for us, please?
Request headers provide additional context about the request. Some examples, that hostexample.com tells the web server which domain the client is requesting content from. Often a single web server will serve content from multiple domains, sometimes called virtual hosts. The server uses its header to determine which content to serve. Accept language, English, I'm assuming. The client lets the server know which languages it prefers the response be sent back in. User agent, Google Chrome 53.2. Which type of client sent this request? Sometimes the server will respond differently based on the UA field. Accept text/HTML, text/plain. What format response is the client interested in receiving? HTML, an image, or JSON?
All right, fantastic. Thank you so much. So all pretty straightforward. Example.com represents where the host is being served or where the request is coming from. The accepted language, which is just English. We have our user agent, where this is being accessed. So either Google or Safari or Firefox or any of those different browsers or maybe something else. And then we have the accepted kind of requests. We could either send text plain or text HTML. All right. So now we have the HTTP response. Once this is finally processed and completed, we get a status of 200 OK. That means it was successful. We get a content length of 424 characters. That's how long the body is, the date that it was completed, and the content type that was being sent. And here comes the body with all the information. Now the response status code. We're going to see the status code represented as a number. The reason phrase corresponds to the status code. So 200 will always be okay. And then which kind of protocol it is, whether it's HTTP or HTTPS. Here's some common status codes. We won't break into status codes until later on once we're working with Django, but you may see some status codes when you're working with other APIs today. So you have 200 OK, you have 302, which is see other, It's just essentially telling you this link no longer works. Try this URL instead. 400 bad requests means the client or whoever is sending the request, you did something wrong. You're either missing some parameters or you sent something in the wrong format. 401 unauthorized just means that you are not authenticated or you are not allowed to be able to interact with that URL. We have 404 not found, which is very common in GitHub. 404 not found is utilized over 401 unauthorized for some reason in GitHub. I've never been able to understand that or why that is. But essentially 404 not found means you can't access this URL. And then, or this URL doesn't exist, excuse me. And then 500 internal server error. So there's a key difference between 400 and 500. 400 means, hey, you, the client, you did something wrong. 500 means, hey, my code, me as the developer who wrote this server or who wrote this API, I did something wrong and my API is not able to process your request. So this means the server is broken or isn't able to function correctly. And instead of getting an error and just killing the server, it's raising an error on their side, but it's still responding, it's still sending a response to the client. And then we have 400, which is just the client messed up. You need to fix this. All right. So now response headers. These headers serve a similar purpose as the request headers. They provide additional context that the client uses to interpret the response. Common responses headers include content type, which is essentially just saying what kind of content we're carrying, the content length, the number of characters inside of the body of the response. We can see this set cookie function. In this case, it's setting the cookie of currency to USD. We're gonna deep dive into cookies. Essentially, cookies are a form of, you place a cookie in a browser when there is something that you want the browser to be able to track, but you don't want clients or anyone to be able to access utilizing JavaScript. Right? That's the whole point of cookies. It's just a more secured way of setting variables on the browser. This requests that the client save a cookie with a particular name and value. Great. And then we see the date, which is the date that the response was completed. All right, can somebody read this slide, please?
Many HTTP conversations. Imagine using a browser, a few pages on a typical website. Dozens or hundreds of HTTP conversations will take place, like loading the home page, HTML, one HTTP request and response, loading CSS, one HTTP request and response per CSS file, loading JavaScript, same thing, and then response per JS file, loading images, one HTTP request and response per image. And that's just for a single page.
Awesome. So just like we talked about, right, when we took a look at our handy dandy example of Amazon.com, and we take a look at the network tab, there is a huge amount of requests and data that was loaded and all these different files. That was just for this one page, right? So we can definitely see how those conversations can pile up. So now we're going to talk about stateless. A very important characteristic of HTTP is that every conversation shares no state with any previous conversation. Every HTTP conversation begins with a new connection from the client to the server. It's as if the two parties are meeting for the first time. Even requests made just moments before have no bearing on the current request. And then we have a server state. Most servers clear all state variables with each request. This means all state when processing a request come from the request itself. All right. So this just goes back to what we were talking about earlier inside of TLDraw when we talked about this handshake. This is either going to keep a line of communication open or it will kill the communication after each request. So this communication will either happen every single time this request is sent or it will continue. All right. Go ahead, Owen.
Is this related to like REST APIs where it's like if it doesn't stay connected, then now it's like, yeah, what you need. I'm just going to sit here and wait for your next request.
Exactly. Yes. So that is essentially what we created with Flask. We created a serverless state, right? Which is just every time we send a request, it responds with our students But then after that, it kills the communication. There's no longer a session going or any sort of variables, right? Every time you sent that request, it's a brand new conversation, as if they never knew each other. Awesome. All right. Oh, there we go. Stateless. All right. So HTTP cookies help retain state, like who is logged in or what was their last search across multiple requests. This might sound like a total violation of the stateless nature of HTTP, but even with HTTP cookies, HTTP as a protocol remains stateless. It all has to do with how HTTP cookies are implemented. So you know what? We're gonna read this cookies in short, and then afterwards I'll show an example. So cookies in short, you'll learn more about how HTTP cookies work, but for now, here's a summary. The server sets a cookie by sending them to the client as part of the HTTP response. The client stores the cookies. The server does not store any cookies. Any cookies for the current domain are sent to the server as part of the HTTP request. So let's take a look at an example here. I'm going to go over to github.com, and you can see that when I went to github.com, I'm already logged in. But how is that possible, right? It's not like github.com saved my credentials in the URL, because that would be terrible if they were saving credentials and showing them in the URL, right? They would essentially be compromising every single user. So how do they know it's me that's sending this request? Well, let's take a look. Again, we're going to go into our inspector tools. And in this case, I'm actually going to go into application. And inside of application, you're going to see this drop-down menu here on the left-hand side, where we have a session storage. And then there's this thing called cookies. Well, if I take a look at cookies, you'll see that my browser, right? These are all the cookies that my browser is holding. This isn't necessarily just GitHub. This is Google Chrome is holding all of these cookies because all of these different sites that I used sent this information. But actually, I think I'm wrong. I think this is just GitHub that's being displayed here, not all of the cookies. So the browser's holding on to this, is displaying this site specifically, cookies that have been sent. So we can see here, domain. This is where the cookies have been coming from. They're all coming from either .github or github.com. There's a path. So it shows me what path actually generated this cookie. It shows me when it expires. So if you've been on GitHub logged in for a while, and then all this, or you haven't logged in for a while, and then you go back and try to log in, and it has you manually type in your username and password, it's because your cookie expired, right? Somewhere along this line it expired. So here you can see, hey, is this person logged in? Yes. And that will expire a whole year from now. I doubt that. There must be a different cookie. Here it is, user session. 11:07. So after today, I have until November the 7th to log back in before GitHub requires me to manually type in my username and password. All right, that's all cookies are doing. There's a bunch of other things that are being saved here. I think this is time zone. Yep. My preferred color mode, it's showing that my preferred color mode is dark. And there's something else with color mode right up there. But this is all being stored by the browser, not by JavaScript or by my server or anything like that. It's being stored inside of Google Chrome. And when Google Chrome sends this request, my server is able to grab all of these cookies so that it can send back the correct information. All right. Does anyone have any questions over what we've covered up to this point? All right. And actually, let me just read the summary, and then we'll open up for questions regarding the slide deck. So HTTP is a proven protocol. It's extensible and has found uses far beyond what was imagined in 1991. It's relatively simple, human readable, and easy to parse with code. HTTP first changed the world by connecting users and servers to form the web. But today, it's the foundation of so much more than the web. You'll soon realize that HTTP is everywhere. All right. Any questions over any of the topics that we covered in this slide deck? All right, I know that was a lot of talking, so let me go ahead and pause the recording here.
Pick something.
All right. Welcome back, everyone. This are going to be the second iteration of our class. We're actually going to be utilizing Fetch to communicate with the Poke API and create some elements inside of our HTML document here. Now, promises are pretty cool. They're super useful, and you need to be extremely comfortable with them by the time we move into, well, actually, from this moment on forward, we expect everybody to be very comfortable with requests and asynchronous requests and the whole shebang bam. Now, when we talk about requests, what we're talking about is this entire process that we've been iterating over throughout the entire duration of the class. Right? We make a request. We're sending a request for information. The server is taking some time to formulate a response, and then it's sending that response right back. Now, it's important to, I have to emphasize this. Server needs time to formulate response. Right? And I say that because remember that JavaScript is just running from top to bottom, right? It's just reading lines of code as it needs to from top to bottom. But when we're sending a request, if we don't have a way to tell JavaScript, hey, you need to wait here until a response comes back from the server, because the server needs time to be able to formulate that response, it's going to attempt to continue on working without actually having the data back from the server. And we're going to dive deeper into that here shortly. Let's do a little bit of a project overview. Here in the backend directory, you'll see that I have my app.py, which is my Flash server. We won't be touching this until after we interact with the Poke API. In models, you'll see that I have my student folder for the model. Inside of this database directory, I have the student's CSV, and I also have the student's SQL. Great. So that's it for the backend directory, or for my backend project. Now, for my front end, I have a folder named static that is holding main.css, which will make my h1 element with a background of yellow. And then I have main.js, which will console.log, hello, I am connected. Great. Well, now let's take a look at what happens when I take this index.html and take it to live server. All right, so here we see this async fetch, which is from my title. We can see that my hello Yankee has a background of yellow, so I know main.css is actually connected. And if I go over to my console, we can see I get this hello, I'm connected from main.js being console.logged. All right, so that is it for my project overview. Does anyone have any questions over the project overview or why things are structured the way they're structured? Right, no questions. Let's go ahead and move forward with today's actual content of our lecture. In this case, what I'm going to do is I want to create a division, which here we're going to name this class, or actually, let's give it an ID of container. And this ID of container is going to have a little bit of CSS styling here, where I'm going to do display flex. I'm going to justify content. Actually, I don't need to justify content. I just need to do something like gap. And let's do 5v min. And then finally, let's do flex wrap. And let's wrap. All right, so as things get generated into this container, things will drop. Now let's go ahead and add a button right under this container. And we'll call this fetch Pokemon. Now, every time it clicks on fetch Pokemon, I want their image to be generated and to load and be displayed up above. So now let's go ahead and go into creating that function. We covered this information yesterday, so I'm going to ask the class to walk me through this process. Again, I want to create an onClick function that will generate an image of 25 vmin for height and 25 vmin for width, and we'll append to this division of container. All right. How do I do that in JavaScript? All right, let's start it off. Haley, can you walk me through just building the structure of the function? You're muted on Zoom.
Okay, so you would first do a const and then whatever variable you want to name it. I think for the but
Okay.
okay. And then
How do I create an image element with JavaScript?
would you do an image container?
Okay, how do I do that?
Just do let image container equal document dot query selector and then parentheses pound image dash container.
I think we named it container in the HTML, but I get what you're saying. Okay, so that's
Okay.
grabbing. Fantastic. All right, let's pass off the baton. Let's see. Let's have Sam. Sam, how do I create an image at this point?
So to create an image, you can do image element dot src, right? Or yeah, image dot src, element dot src.
So you're saying do image element.
Yep. Dot src equals whatever the image is in quotation marks.
Okay,
So dot JPEG or whatever it is.
yeah, in this case, we're not have an image, so we're just gonna put it in pound. Now, this is really interesting. We're calling this image element, which
Mhm.
we could either have image or image element or whatever we would like to name it, but I don't think image has been created yet. How would I create image in itself?
You can make it as a variable like let
Okay. And what would I set that?
image equals trying to think. Not too sure actually.
Okay, awesome. Let's pass it off again. Let's see. Let's go with Juan.
Me or the other one?
Do we have both of you? I think it's only you this time. Yeah.
Oh, okay. Can we make an actual image tag like open tag img, close tag img?
Yeah, I think in this case, what we're looking for is we would do document dot create element img, right? So this would create the image element. Okay, and we gave it an image source. And now I want to set both of those styling attributes of width and height to 25 vmin. How could I do that, James Cromer?
We should make two more variables, image dot width.
Okay, so we have access
Oh,
style.
style dot width. Okay. And then set it to, I don't know, 200 pixels or something, just whatever we would want. Oh,
Okay.
vmin, excuse me. What was the other one you wanted? Sorry.
Width and height.
Oh, height. So then the same thing, image dot style dot height. And yeah, same variable, 25 vmin would be good, probably.
Okay, awesome. We have some squares. let's actually give it a border as well. I'm gonna take care of that one. Let's do border. Oh. And let's make that solid, 1 pixel, and let's do black. All right, great. So now we've created an image. We may have an image source to actually be able to attach here. Now the last portion of this function that we need is actually placing it inside of the image container. How do I do that? And let me pass that off to Tristan.
Excuse me, I'm trying to remember. So to actually get the image in the image kit, wouldn't you need an image for it to be able to use?
So we have the image created, and right now I'm just giving it the £.
Oh, you're just giving it a pound sign?
Yeah,
Okay.
it's gonna show up as like a broken element, but that's okay. So how would I add this image into the HTML document? Because as of right now, we created the image and we have all these different attributes, styling attributes set for the image, but we haven't added it into the HTML document. Want to pass it off?
Yeah, I'm a little lost on this. I'm not gonna lie.
All right, awesome. Let's pass it off to Owen.
Okay, so just do document dot your. I know you can append, so but like you'd have to put it in either in the body.
Yeah, I think we
You do like document dot body dot append, and then your image.
that is one way to do it, right? We want to append child. But we grabbed this image container earlier. Why do we grab that for?
To actually insert the image. So like then you do image dot image container.
All right, so we grab image container.
And yeah, now it's kind of getting shaky on me. Could you use dot append?
Yeah, we would append child.
Okay.
And then pass in your image. All right. Gary, do you have a question or do you have something you want to add?
No, that was it.
Okay, awesome. All right, so I've created this function that should be able to add an image into my document, but it's not connected inside of index.html yet. Right? This is an onClick function. So how do I attach this onClick function to my button of fetch Pokemon? And let's go with Jesus for this one.
You want to attach it to the button link.
Okay, so I have my button and I want to be able to have an onClick function on it where every time somebody clicks that button, it triggers the function. How do I do that?
So you just put button on click, all lowercase, like inside a string. And then you'd put just click.
All right. So we just click. All right, let's try that out. Let's see what happens when I click on this. Seems like I'm not getting anything, which is actually surprising. I totally expected it to throw an error. All right, so
Do we need to attach it to the function, the JavaScript function?
okay, so we named it get Pokemon image. So how do I
Put it inside the click parentheses
okay,
to
so
call it.
Pokemon image like that?
Yes.
I think we're close, but we
Do we
maybe
need the click?
no, we don't. So
Okay, can we just call the function then, and then the parentheses on the outside of get Pokemon image?
fantastic. And now when we do it, we get our images populating with a nice little gap in between them. Great. All right. So we were able to create our images now. Fantastic. We did a quick overview over how to create elements and manipulate the DOM with JavaScript. Now let's go into actually fetching data, right? I want to grab data. from the Poke API because every time I generate a Pokemon or every time I get a Pokemon, I just want to grab a random Pokemon. So let's go into that. Let's break down this code with some pseudocode. So create a function. This function will generate a random number between 1 and let me actually find out how many Pokemon they have available. 1302. We don't need that many. Let's just go with 1000. All right. So generate a random number between 1 and 1000. Once it generates this random number, it will fetch Pokemon data corresponding to rand int. It will then iterate through response to grab front default sprite. We'll go into that as well. Return front default sprite. All right. So if I put in 1 here and I click submit, it's going to populate in this way. If I come down to sprites, we can see that that is a key for this massive object. And inside of this key, there's another dictionary, or excuse me, another object with the key of front default that returns to me the Pokemon image that I'm looking for. All right, come over here, send it over. We can see a good little Bulbasaur popping up. All right. So now let's create this function. Again, if you guys could walk me through the process of creating a function, what would this look like?
Same thing as before, const get Pokemon image.
All right, let's say get Pokemon, and just to have a different name, let's call it front default here. eBurst. There we go. All right, now how do I generate a random number in JavaScript between numbers of 1 and 1000?
We could make a new variable like let number equal masked out random. And then in there you could put 1 and then 1000. So it could pick a number between 1 and 1000.
All right, awesome. And I believe we also have to put this in math.floor, but I may be wrong. I'm just gonna put it in there just in case. All right, so there we go. We have a number between 1 and 1000. Fantastic. Okay, now we're gonna get into the fun part where we are fetching data. Now, we haven't learned this yet, so at this point, I'm gonna go ahead and take over the building of this function. We know that at the very end, we want to return a sprite, right? So now how does fetching data work? Fetch is a built-in JavaScript function. And inside of this fetch parameter, well, just like when we go into Poke API, it's telling me, hey, this is how you run a request. I'm actually gonna just copy that URL. I'm gonna paste it right inside of the fetch function. Instead of that number 1 at the very end, though, I'm going to utilize string interpolation to include that number that we've created. So now fetch gets sent. But let's take a look back at our drawing here. Fetch gets sent, and now it's expecting there to be data to work with, right? Or it's waiting for this data to be populated. But again, remember, a server needs time to formulate a response. So how do I tell JavaScript, you need to wait for this response to come back, or you can't move forward until this response comes back? Well, we do that utilizing the .then method. Dot then says you will not move forward until a response comes back from the server. And then we're going to turn it into JSON, but let's give it a second here. Let's console.log and do response. And I'm actually going to change this for get Pokemon front default for now, just so we can see how it works. Let's inspect our console here. All right, so now when I clicked on that function, you can see I console.log the response. And this is what we get. We get, hey, there is a response and there is a body within the response. Here's all the headers. Here's whether it was okay. We're getting a 0 for that response. And I believe that's because of my math.for, but let's try that. Okay, so now we're still getting a 0.
Oh yeah. Sorry, I think I did it wrong on that. It's just parentheses for the random and then times 1,000.
Ah, got it.
That actually explained a lot for me yesterday because I was wondering why, when we were trying to get images and stuff, like why are we multiplying by that number? So, okay, thank you for clarifying that for me.
Fantastic. All right, so now we're actually getting an okay equals true. All right, so we saw that in the headers. It's telling me, hey, this was successful. But I don't have access to the body. It's telling me, hey, this is a readable stream, but it's locked, or it's not really anything that I can utilize as of right now. Well, how do I fix that? Well, as we know, all of the communication that happens between web development nowadays, or most of the communication that happens in web development nowadays, happens through JSON. So in order to grab our JSON data, all I need to do is called response.json. And that will grab my response and turn it into JSON data. Now, again, this is a pretty hard function, or a function that's going to need time to be able to work. So now I need to utilize another dot then. I can then call the data. And inside of this data, I can console.log data. Now let's see what happens when I press that button. Well, now I actually get back my object from the Poke API. All right, so the Poke API displays, hey, here are some abilities. This is what it looks like. I can click on view raw JSON, and this may seem a little bit more code readable for us, right? Well, that's exactly what's happening in async fetch. I now have abilities. I have cries, which is actually pretty cool. You could play those if you really want to, if you ever want to implement them in a site. I have all the moves that this Pokemon can learn, which is only 98. That's pretty surprising. Here we see the name of the Pokemon. And then we see sprites. Okay, so now we actually have data, or something that we can work with. So now let's go ahead and iterate through the response to grab front default from sprites. Okay, so let's go ahead and make our variable here. We're going to call this let front default and make that equal to something. So if data is just the entire JSON object that comes back from Poke API, how would I grab the front sprite element? So let me close all of this so that it doesn't get in our way. Okay, there you go. All right, let's hear one.
I'm assuming you could just use your keys and then just iterate through or go deeper down into the object.
Exactly. Awesome. Perfect. So what would be the first key that we need to call?
Sprites, I think. Yeah, sprites, and then from sprites you can open that. Or the first one.
Awesome. So
No, that's right there, front default.
data dot sprites dot front default, and that will return that Pokemon image. Well, let's console.log that to make sure that that is the case. All right, we come back over. We click on fetch Pokemon. And if I click on that link, we can see that it gives me a nice little Pokemon link. Fantastic. Everything is working just how we wanted it to. And now, what we can do is we can change this function where it takes in a source as an argument. And we can set it to source. All right. So now that we have our front default, we can call our function here. We can call get Pokemon image and pass in front default. Well, let's take a look at what happens when I execute this code. Click on fetch Pokemon. There we get, I don't even know what Pokemon that is. We got Bulbasaur. Don't know that one either. There's, wow, I haven't played in a while. All right. There we go. There's some familiar faces. And we're getting a random Pokemon between 0 and 1000 every single time we continue pressing this fetch Pokemon data. So let's break down how this happens, right? From the moment I click this button, what happens? So I click on the button, the get Pokemon front default is triggered. All right, let's take our image a little bit further down here. Let's just roll out our steps. There we go. All right, so click on button. Okay, great. So I click on the button and the function gets triggered. So the first thing that happens is we generate a random number, which is greater than 0, but is also less than 1001. All right, so that's what we do. We generate our number. Well, the next thing that happens is we utilize fetch to send a request for Pokemon. All right, well, what does that look like? Well, if we come up above, this is what we're talking about, our fetching our requests, right? So front default generates number, goes into fetching. Once the fetch gets triggered, that request is being sent to the backend server. The backend server is just a Poke API. They're running some sort of server in the backend. I'm not sure what their tech stack is, but judging by what they have here, I'm assuming that it's built with some sort of C# language. But there you go, right? The request gets sent. They, on the backend, so at this point, what we're doing is we need to wait for data to be formulated. So how do we wait for data to be formulated? Is we utilize .then. Wait for response. All right. So let's go ahead and utilize our arrow here. We're coming down and then we hit a stop sign. Saying, hey, I need you to stop. This here is important. We need you to stop and wait. All right. So now the Poke API now has time to ping their server and ping their database, grab all the data from the database, format it the way they want to be formatted, and then send back a response. Great. So then we receive a response. What's next? Well, now we need .then, or we need to turn data into JSON readable format. And again, we utilize .then because we are waiting for data to be transformed. All right, so we come down here. It reads through this portion of reading data. And then we get another handy dandy stop sign saying, hey, we got to wait for this data to transform. Okay, awesome. So the data transforms. And once the data is completed transforming, it then goes, all right, well, we're going to iterate through data object and grab front default sprite. That then gets fed to the get Pokemon image, where the get Pokemon image grabs the image container, creates an image element, and then image is appended to the image container. Oh, hello. And that kills our function. I mean, that's the very last step of our function. So that's what we're doing. From the moment I click that button, we generate a number. A request for data goes out to that server. We need to wait for the server to be able to formulate a response. So we wait. Once we have that response, we need to transform that data into JSON readable information. So that's this response.json here. We then need to wait again because we need to wait for that data to be transformed. Once that data is transformed, we iterate through the object, feed that front default sprite to get Pokemon image. Get Pokemon image grabs the image container, sets the appropriate attributes and source to that image, and then appends it to the image container. All right, James, let's hear it.
I'm curious, with the two then statements on 1920, I guess it's a two-part question. One, I'm curious why there needs to be a second then statement exactly. Is it if it's just to wait for the data to be rendered, and also how does it know that that data is corresponding to the previous then statement of the JSON model?
Awesome. So we're talking about these two .thens. So these two .thens, .then is a function that takes in a function. So all we're doing is we're specifying, hey, this is a function in here, right? And this function takes in a parameter. Now this parameter, I named the response. I can name it anything. I can name it ASP. I could just put a bunch of different things in there. My favorite one to use is just RESP, short for response. But this is just a parameter that you can name it whatever you want, right? Then knows that this function is going to take in the return value of fetch. So fetch gets a response. Now we need to wait for that response to be completed. So this generates a promise, right? So generates promise. We need to wait for that promise to be completed. So then grabs that promise and waits for it to be completed, right? Once that is completed, we need to formulate into JSON. So turn response into JSON data. And we do that with response.json. Again, that is a function with a return value. It's going to return a promise. So generates promise. That promise is again accepted by .then as data once it's completed, right? So it's just a hand-me-down. That's why it's being indented as well. Technically, we could indent again, right? Just to demonstrate how this is working. So the return value of fetch gets fed to .then as response. The return value of response.json gets fed to .then as data. Does that answer your question, James?
Yeah, I think so. I think the indentation made it a little bit clear that it's really like waiting for the previous step to finish, and then it will take what that previous step did and continue on with the function. Cool. Thank you.
Of course. All right.
Hey, can data be anything in there too, like response or no?
Yeah, data can be anything as well. We could name this, I don't know, body. And that,
Gotcha. Okay, thank you.
of course. Jacob?
Yeah, on line 22, like I get that like you're accessing like the actual sprites object inside of the Pokey API, is that correct? Like to actually get the front default. Um, so like if we're working on our own thing and we're trying to do something similar but with like a different site, I guess, how do we know like where the objects are and what they are so we know so it knows what to grab? Does that make sense?
Yeah, it
Like
definitely does. So if most API, so let me see here. Rick and Morty API. So most APIs will have something like documentation. And you could take a look at the API here and it will tell you like how to work with it, right? So for example, if I wanted to just see, hey, I want to get all the characters. Well, it tells me when you send a request to this endpoint of get all the characters, this is what I'm going to return. And then from there, I can see, oh, in the key of results, there's an array of objects. And in that array of objects, I have Rick Sanchez as my ID of one. Right, so it's just about reading their documentation and trying it out. Some of them are even fancy enough to where they have a playground. I don't think this one does. Oh, look at that. It has examples that you can utilize too. Nice. So they have all kinds of examples that you can utilize as well, if they don't have a playground. But it's just more about looking at their documentation, seeing how their responses are being formulated and responded back. And then from there, it's just trial and error, making it work with your program. Does that answer your question, Jacob?
yeah, thank you.
Of course. All right, Ryan. If you're speaking, you're muted on your headset. I can't hear you. All right. I'll wait for it in the chat. James?
Yes, can you hear me?
Yes, I can.
On your JS script on line 6, when you used source, do that fall in the same category as response and data? Because I'm just trying to figure out, like, why did you use SRC? Where did it come from? Oh, never mind. I see it up there. God damn it.
Yes, so SRC is the parameter that got passed in, and then I passed it down here below.
It's okay. I answer my own questions a lot too sometimes.
No, that's fair. That's bad naming convention. I should not have named them source, considering that the image source parameter is in there. Let's go ahead and let's just call this IMG SRC, and then we'll do the same thing here. All right. Awesome. Any other questions?
Kind of maybe unrelated. Is there any way you could demonstrate how to grab Rick Sanchez from the Rick and Morty API? Or would that take too long?
No, I could definitely demonstrate that here shortly. Yeah, absolutely. All right, let's see. Rick Sanchez image. All right, we could do that. Let's see. Grab a character API. It's only going by IDs, it looks like. So you can get a single character by adding the ID as a parameter. Okay, easy peasy. All right. So we've just covered how to utilize fetch and .then, but this is where JavaScript gets a little crazy because there's a couple of different ways to send requests, right? We can send requests and utilize the .then method, which works perfectly fine. But there is also something called async and await. So for asynchronous functions, we're just getting rid of this whole .then indentation and crazy stuff of continuously passing in functions within a function and just kind of writing regular lines of code. So let's go into get Rick Sanchez. And this is going to be an asynchronous function. This is telling the program, hey, this function may require us to wait for data, right? So what signified earlier that we needed to wait for data was the dot then. Now I'm telling the program ahead of time, hey, you're likely going to need to wait for data. But we haven't exactly told it when to wait just yet. It's just saying, know that this is going to happen. All right. Well, I'm going to say const pass in response and make that equal to await, and then pass in fetch. And in this case, since we're working with the Rick and Morty API now, I'm going to go ahead and copy this URL. And I believe Rick Sanchez was number 1. Yep, so he's number 1. So there we go. That should get us Rick Sanchez. And let's take it a step at a time to see what this returns. Let's console.log response. And let me switch my function to, instead of, actually, why not? Let's just create another button. Rick. Yeah. All right, and then on onclick, this is going to call the get Rick Sanchez function. That's what I named it. Get, oh, look at that. I would have messed it all up. All right, so get Rick Sanchez. Come over here, we click on it, and it tells me, hey, here's a response. Just like we saw earlier, it's a response. We awaited for the server to be able to grab data from the database, format it, and send it back. But it's not in JSON format yet. So again, we're going to need to wait. Right? We're going to say const data. We're going to make that equal to await response.json. And now if we console.log data and click on pickle Rick, or now we can actually see, hey, here is the data from the Rick Sanchez API. And I believe the last part that I need is going to be image. And we can see that that is a key in my object. So now I can pass it to the get Pokemon image function. And pass in data dot, oh, I think it was just IMD. Right? Is that what it was? Let's see. Nope, it's actually image. All right. So now when I click on Pickle Rick, you can see Rick Sanchez populating. And if I click on Fetch Pokemon, we can see a random Pokemon populating. I can mix them. It's just data coming in from different APIs. All right. So that's the key difference. We're still waiting. The only thing is that now instead of utilizing .then and passing a function, we're just saying, hey, I want you to wait for a response to be generated. And instead of saying .then for response.json, we're saying, hey, I just want you to wait until response.json returns some JSON formatted data. And then we pass it into the same function. All right, Juan?
Out of these two methods, I'm assuming the async method is the preferred one to use in like real applications or something?
No, actually. So to today, as far as I'm tracking, the preferred method is utilizing .then, because .then has an attribute named .catch that allows you to catch errors and error handle right away. Whereas this does not have a catch attribute. So essentially, when I send this request, every time I trigger a .then, so I could have gotten an error here, I could have gotten an error here, and I could have gotten an error in here. So there's 3 different places where I could have triggered an error. And each one of these .thens could have a .catch attached to them. All right, we could just unindent it and have a .catch. So at each level, it's being able to identify, hey, this is what went wrong, and send an alert. In the asynchronous method, it can't do that. In the asynchronous method, I would have to place my entire code inside of a try and catch block. And it wouldn't be able to identify in which one of these steps it caused an error. It would just tell me the error message, but not tell me where inside of the body of the function this error is happening. All right, so .then is still the preferred method, but definitely asynchronous will save you some time if you're trying to kill a function quickly. And, you know, it's definitely user's preference. I don't think anybody would really, you know what, I stand corrected. If you go into industry standards, they're more than likely going to expect you to utilize .then. Just make sure you know how to utilize async and await in case they want you to demonstrate that during an interview. Does that answer your question, Juan?
Yes, thank you.
And I saw a hand go up and then it went away. I apologize.
You
Yeah.
answered the question. I was just gonna say what dictates between then and async, but you said that then is the industry standard, but you want to be familiar with both.
Right. So async and await is something that's been more newer. And again, the only reason why people still prefer .then to this day is just because of the fact that you're able to catch errors at the exact level where that error it populates.
Francisco.
Yes, sir.
So what I was gonna ask was, is it typical to use maybe like 2 or 3 different APIs for the same thing in case one API switches up, or how does the industry handle that, I guess?
It definitely is typical to use multiple APIs to be able to generate content. You'll notice once you go into your personal projects, you're going to likely utilize 3 or 4 APIs by the time you're completing your personal project. Right? This alone is utilizing 2 APIs, and we can see how APIs are very powerful. It's not like it creates some sort of extra load on my application. Right? If I go into my network tab, we can see all the requests being made. And it gives me in color codes like, hey, this is the API that you're utilizing. All right, I can take a look at the request and do a couple of other things inside of the network tab. But no, it is not uncommon to utilize multiple APIs to be able to generate content. As far as to be able to accomplish the same goal, you could use them to bounce off of each other and to ensure that they have accurate data. I know there's like apps that utilize marketing or sales or stocks. They try to stay as close as possible to like the most accurate intel, and some APIs don't update as fast as others, so they're always just bouncing off separate APIs. Does that answer your question, Demi?
Yeah, it does. Appreciate it.
Of course. Any other questions? Okay, if there aren't any questions, we do have another lecture this afternoon. So let me go ahead and stop our recording here.